mastered it. I need to time myself because otherwise I talk too much. All right. So I like salamis. I'm in the business of not producing salamis, maybe, but maybe the mini pig. So somehow, so this is kind of a summary of what we do daily and kind of examples what's working, what's not. I'm a physicist by training. I was there when the Rosetta mission landed on the comet. I'm serious about pizzas, coffee, and this type of racket sports, which I know actually Thomas from our epic tennis battles. So if you want ideas for icebreakers, just say anything of those buzzwords and I'll be all ears. And this quote I wanted to just put on somewhere, and it's about the hype thing. So machine learning is like teenage sex. Everybody talks about it. Only some really know how to do it. Everyone thinks everyone else is doing it, so everyone claims they're doing it. I think it's kind of a few years old already, and it was originally, I think, with data science, but as I said, all the big data hype is now the AI hype, and I think it's as relevant as ever, and it's always something to keep in mind. I work at Parashift. I'm the head of the machine learning group. We are 5 people in the machine learning team. The whole company is 35 people. Just a little bit of context so that you understand all the examples I'll be given are kind of document understanding driven. Basically, you send us documents. We send you a couple of things back. We can kind of intelligently separate batches of documents. So we just brand the whole inbox to your scanner. We separate them, say this is a document, this is another, this is another. Then we classify them into different types of documents, and we extract some information depending on what kind of document it is. And this really does not have to be like the classics, like contracts or invoices or anything. You can put your gym memberships, your driver's license, anything you have it. You can train your own models, but we have a lot of out-of-the-box stuff. And we're a full cloud solution because every time everyone wants something on-prem, a puppy dies. No one wants that. Yeah, so first things first, never a good thing to assume you know anything, and that's true on both sides. I think the customer side and the actual ML kind of engineering side, because we usually talk different languages, and it's difficult sometimes to kind of convey some knowledge. There's also different expectations from people. Some think, okay, it's ML, it's AI, it's magic, it will work out of the box 100% of the time, it is never wrong. So it's important to talk to customers about expectations. Really, can you use machine learning in your workflow or whatever in your daily life? What are kind of the necessary requirements for it to be useful? Because sometimes for some use cases you would need a very reliable system that is correct 100% of the times. Then most of the machine learning approaches probably won't fit for you, because if you're really screwed, if you make one mistake, that's not for you. But maybe if the model is already 80% right, it can already reduce your workload by 80%. It's a good idea. So that's all things that sometimes only surface after effect once the customer buys the product, and then they say, well, this is not useful because it has 2% error rate, and I expect 0. Then you say, well, yeah. And sometimes you really don't need ML. I mean, a great example was a guy used ChatGPT to parse HTML. Absolutely useless. We solved this like 20 years ago, I think. There's like cheap algorithms to do this. If you want to find some like specific AHV numbers in Swiss documents, it's also fixed pattern. No need for machine learning, even though it's cool, it's fun. It starts usually to get interesting if it's more versatile, like you have an IBAN or a big number, which is surprisingly different from country to country. So you can already start to think about machine learning, because then just throwing data at the machine is cheaper than to have the whole configuration set up and all the special use cases. So it's kind of a weighing of what's good and bad. And here's an example of good versus bad mistakes. Some customers are not aware, like the machine learning model can make different types of mistakes. And some are good, some are bad, and it depends on the use, on the context. And here we have an example where they need it. Does this have a laser pointer? No.
If you press the top button long enough, you'll see the pointer. It's not a laser pointer, but you can move the cursor around.
Ooh. Oh. All right, these are all kind of different types of documents. This is what they really are, and this is what the machine thought it is. So if it's on the diagonal here, this is called a confusion matrix. If it's on the then it's correct. If it's off, it's not correct. But you can see here that we have drawn with the customer these blue boxes. So this is kind of acceptable mistakes because it's relatively simple document. So it's actually an acceptable mistake if you are only confuse your. Oops. Yeah, just leave it. So there's bad and good mistakes. Basically, if you're within the square, the other is within the square. It's a good mistake. But if you confuse, for example, a receipt with I don't know a rental contract, it's a bad mistake. But it's usually a lot of discussions to be aware of also with customers. And this is some just battle stories, also from the great philosopher Mike Tyson. Everybody has a plan until they get punched in the face. That means your model, your ideas, they usually don't survive first contact with reality. And my really first task was just find out when this document was created. And some documents have multiple dates on it, so it's like an easy task because it's obviously going to be a date, but it's not sure which date exactly. And so you can see here there's obviously different dates that you can do it, and I trained my model on the data, and then literally this was the first date that a customer sent me. Like in December 19, which my model of course completely failed. Then we have examples of people putting receipts on maps apparently. So the OCR engine picks up all kinds of funny places like Bern, Zurich, whatever, and the machine gets totally confused. So you have to build something that just focuses on the actual receipt because you didn't think of this. Then we have a chicken egg problem, right? There's no data, no model, no customer, no data. So you have to actually start slow. And we did this, so we had kind of a family, fools, and friends situation. We collected documents ourselves. They were mostly German. First customer, I think one of the first customers, not the very first one, the German travel agency. So yeah, that's cool. But then it turns out all their hotels are in Spain. So all the invoices were in Spanish. Absolutely useless. Nothing worked. Again, back to the puppies. Of course, you produce your first model, you put it into production, so it's in the real world. You're happy, it makes predictions. But then the real hassle only begins. Like training a model is a lot of work, getting the data, but actually keeping your model going is a big task. So you have model drift, which means usually you only train on as little model data as possible. But then new data comes in, maybe the data changes over time, and you want your model to adapt. So you train your model with new and better data, which is all cool until you realize, oops, my virtual machine that I have doesn't have enough memory. So my training cycle actually died, and I didn't have any supervising mechanism in place, and I didn't actually realize that for 2 weeks this whole machine hasn't been training, and everybody's complaining. You do software updates, the whole thing crashes. Google does on their machine. They replace the latest GPUs with the old GPUs with some new GPUs. The drivers are not compatible, so it's a whole thing. Basically, you need to put. I think you can get away if you have like 1 or 2 models in production that you can do this manually and can just like take care and check after the model. You go after your morning coffee, you check after the model and see if everything is working. But we have, I think, somewhere north of 1,000 machine models deployed and trained on a constant basis. So we need to have everything automated, and every little change is like nerve-wracking. So you get angry calls at night or stuff like that, right? So we have these reporting things where you can see this is all the trainings that are going. So trainings are running or are already completed, and you can see at any time we have up to 40 or 50 different models that are being trained. So this is all fully automated. And then we have a reporting mechanism in place where it can actually monitor all the performance of these models. And this is also a bit of a problem that we have. We're kind of a smallish startup, but we have an infrastructure that's more of like a big company because it's a little bit of a complex thing. and we're slowly getting there. Another way how we stay out of trouble is we don't interpret any data. That means we just read out whatever's on the document. We don't do anything like we read out, you paid 55 Swiss francs for 3 pizzas. We don't tell you, oh, you overpaid or you underpaid. We just read it out. And that gets rid of all the lawyers and everything else, and all the ethical concerns that we also have already heard before, because models are fundamentally built from data, and every bias that is in your data set will end up in your model, will end up in your predictions. So that's a big problem that we already heard of. Then the black box problem also, but there's a lot of research going into there, and that's I think actually it's pretty exciting that machines do some of these or take some of these responsibilities to take decisions, because you can actually, it's also, people like to think that humans are rational. And I mean, if your loan gets not allowed, or you don't get a loan from a bank, I don't know what is more rational, to like argue with a human person that was there or with a machine. As a machine, you can actually, there's going in a lot of effort with counterfactual experimentation or examination of the model, where you can just, let's say you want a loan from a bank and you get rejected. So people, you can pull up the whole framework to critically examine the results. So the goal is then to find the smallest changes that you have to do to your input to actually get the desired result. So what would I have been doing differently to actually get the loan? And then you can see, maybe I'm too old already, so I will be likely to die in the next 10 years. Maybe I earned not enough money this year, or I live in the wrong area. So you can actually get some interesting and insightful things out of this. So I think it's not always a black box, but you always have to like put in some effort into examining this for it not to be in the black box. And then of course data protection. We saw all of this. And then always we get slapped in the face a lot by customers. You can see it here. Careful what you report, because you report numbers and you're always proud of your numbers. And then you say, well, my model works great. I produced this super nice salami and everyone loves it. And then they say, no, it's bullshit. I tested 3 examples and it's actually crap. And that can mean like both people can be right at the same time, right? So you tested it in 100,000 examples and you made sure that you have a representative data set for testing, and the model has never seen it, and all these nice things, because it's not that trivial. Like, it's not super complex, but it's also not super obvious on how you actually evaluate the performance of these models. And there's some terms, like before machine learning, I wasn't aware of the English language, that there's a difference in accuracy or precision. So you can see here, this is kind of a sketch, a cartoon on showing this. So this model just sprays around the predictions all around. So it's low precision and low accuracy. This has high accuracy because it's close to the center, but low precision. And this here finally has high precision and high accuracy. So there's some lingo that you need to understand on what's going on. And of course, it's all about the data. We heard if you train your model to recognize cats like this, and then your customer comes and he produces actually images of cats, it won't work. And that's basically the final model here, that really, if you ever deal with machine learning models, it's all about the data. Like, good data beats good algorithms. It's been true for forever. Like, since I know, it's like one of the, and people are always surprised that it's really that important. And I think it's also one of the greatest breakthroughs with the latest ChatGPT or GPT-4. It's like they have really high quality data. And I have an example for myself. We wanted to improve the score. Let's say the score is terrible at 0 and perfect at 1, and the customer wanted 0.85. We landed out of the box. We landed at 0.7. I said, yeah, that's not good enough. We're not giving you any money. We're unhappy. Blah blah blah. Product team freaks out. They say, well, it's a super important customer. Let's put all our heads together. We deal with data post-processing improvements. We improved the score by a bit. And we introduced some rule-based tops on top of everything, improves a bit. we tweak the ML model architecture, make it more fancy, it increases it by a little bit, and then in the end we just clean up the fucking data, and it's just magically good enough. So also, the fun fact is the evaluation was done by the customer. So they were super critical about the machine learning results. And then actually when I applied the same metric to their hand annotated data, because it's also annotated by the customer, they got a score of 0.2. Orders of magnitude worse than the model. But humans are somewhat always convinced that they won't do any mistakes, even with the simplest task. But it's super hard to actually produce consistent data and just be focused for like 8 hours a day just to, like in this case, to like annotate stuff on just boring documents. And yeah, that's the last slide. Yeah, data's gold. There's a few things going on to make this cheaper. There's like self-supervised learning, semi-supervised learning approaches where you can find smart ways to produce labels yourself. For example, in the language models, they do this by training when you take a sentence and you block out a word, and then you know which word you blocked out, and then the model has to correctly predict this word again. So all you need is just text, and you randomly strap out data, and then you can produce pretty cheap data. Semi-supervised means you have a little bit of annotated data. And as we also have seen before, this will be super interesting. What happens now with if we have something like a conspiracy GPT that pollutes the internet, which ChatGPT is trained, and the cycle just goes on, because right now I think we are at kind of a sweet spot, because ChatGPT produces actually nuanced answers. So people are very biased nowadays. They have strong opinions, and it's always this or it's that. And ChatGPT, I think they put very, very much care into not being too much biased. So now they're talking about or thinking about watermarking the language models, which is also kind of interesting. So you can kind of watermark the output, and you can detect if it was created by your own algorithm at least. So they don't have a method of finding out if something was produced by conspiracy GPT. There's no like obvious way, but for your own product, you can actually do this in a quite efficient way, where you just produce blacklist, or no, I shouldn't say blacklist anymore, a red list and a white list, a green list of good and bad words, and you kind of, when you know from each word, this flops around, and so you have a different list of red and green words, and depending on the statistics, because if a human writes it, it'll be just 50% red and 50% green, and if the bot does it, it's all green, for example. And yeah, that's it. So I'm at the end.